Okay, this is Construction Technology Unit 1, Shed Hackers. Hope you find this useful. It's for Level 1 and Level 2 award and also extended certificate students. So let's see how we do together. As I say, it's Unit 1, Construction Technology. So look at your paper, look at the questions, point out the keywords, perhaps even underline the keywords. It talks about performance characteristics here. And be very careful as you go through the questions to read the points really carefully. It says, explain each performance requirement that has only one way it is achieved. Okay, it's only one way it is achieved. And you have to match these up with these. Okay, and you can see there's 5 points here, and the performance requirements there's only 2. So strength, is it related to stress grading of structural timber? Clue there, structural. Is it to do with provision of ventilation? No, because that's the movement of air. Use of fire-resistant paint? No, nothing to do with fire-resistant paint, is it? Installation of site accommodation. Installation is putting in place. And site accommodation, as you know, are the huts used to hold the site managers and perhaps first aid unit and welfare units on site. So there's nothing to do with that. Sustainability, we'll go on to in a minute. So going back to strength, sorry. Minimising construction waste. Well, nothing to do with strength, isn't it? So the obvious answer to me is that one there. All right. Use of stress graded timber. Okay. Structural timber. And that's obviously to do with strength. Stability. Stability is to do with something that can last forever, or the use of something, perhaps even in terms of a process or materials that you can carry on using forever without damaging the planet. And so I think this is more to do with, let's see, is it to do with ventilation? No. Is it to do with fire-resistant paint? No. Is it to do with installation of site accommodation? Absolutely not. So it looks like it can only be this one, minimising construction waste, which is right. Right, so we'll put an arrow there. So the answers are very logical, I think, and hope they are for you. So moving on, part B here, name 2 locations in a building where insulation material can be placed to reduce heat loss, to minimise it, to reduce it. Well, it's probably going to be inside the wall space, the cavity, wall, space, or void. Okay, and it's the bit between the blockwork and the brickwork, and you put insulation in there, don't you? And then another place would be above your head in the floor space, floor space below you, and the roof space. Above you, and of course floor space below you. If you've got a suspended floor, even in solid floors, you can put in insulation as you build up the floor slab. And I'll perhaps talk about that in a minute. Identify 2 types of sound insulation. Well, it's not tile battens, that's outside the roof, there's nothing to do with it. Metal stud, possibly if you could put insulation in it, but probably not so useful in this answer. Plasterboard layers, certainly. So we'll put that, plasterboard layers, because you can get insulated plasterboard. And interestingly, you can use flooring mats to reduce sound, increase sound insulation. Not ventilation ducts, that allows air, and in fact that allows sound insulation to travel through, sound to travel through. Okay, and we have identified 2 types of loads that buildings are designed to resist. Well, you've got dead loads, they're the loads of the actual building, okay, things that don't move inside, usually the building itself. And then you get dynamic loads, and these are loads such as people and things that actually can move, so you actually have a moving load. Dynamic loads sometimes can also mean things like furniture, things that can come in and out. They don't move, but they can be moved, okay? So books in a library, in a sense, are a dynamic load. but dead loads are those loads that are as part of the building. Block work, brickwork, concrete, all the things that included in the building. Concrete slab, I was going to say that for the floors. Okay, moving on. Okay, so we have question 2, and it says, here's an example of a risk assessment and the control measures. And we're to complete the diagram there, and it gives you an example. Here's a hazard, there's a risk, and there's a control measure. So the hazard, damage to gas service pipe. The risk is asphyxiation, if I can say the word, and explosion. And the control measure is locate underground services and obviously turn them off in some way. So know where they are before you even do any excavation, if that's what's caused the damage. Okay, and the one we've got to fill in is water in a trench. Well, the risk is this. Possibly somebody drowning, but possibly the trench collapsing. That helps. So if you're working in it, of course you could drown, or you could get certainly very hurt. The trench collapse will certainly crush you. And I suppose the control measure would be, therefore, for the trench collapse is to support sides of excavation. And if it's a drowning hazard, remove water. Remove water, and you could pump that out. And removing the water actually allows the sides to become more stable and reduces the risk of the sides collapsing in the first place. And that's what you tend to see, don't you, in excavations? The sides are very supported, and they should be. Identify on question 3, identify 2 site setup activities that are required before, important, construction work starts. So this is before any work starts on site. Right, I can see, well, site accommodation, welfare facilities, that's definitely one. And temporary lighting, you need lighting in the darker days, don't you, in the winter. It has nothing to do with the actual other points, which are construction activities, aren't they? So these other ones are to do with construction activities, which is what they don't want, is before construction starts. Okay, so number 4, doing well here. Identify one statement below that best describes a strip foundation. Well, let's see. It is often used in house construction. That's true. It is often used for high-rise building. No, it isn't. It is expensive to construct. Yes, it is, I suppose, to some degree. It is used when soil is weak. Yes, it is. But the most relevant, I think, is this one, A. All right, the most relevant. And part B, the diagram 1 shows a section through a pile foundation. A section as if you cut it through with a knife. You're looking inside it. And the pile foundation is the type of foundation that supports the wall above or the floor above. So this is a large round tubular shaft of concrete driven into the ground, often many meters, 5 to 10 meters, even more, and it forms the foundation to support the walls from a reinforced concrete beam, as you can see here. It says label the 5 parts of the foundation shown below. Well, this is quite easy, I think. There's obviously the concrete foundation, and that would go meters into the ground till it reaches something stable, perhaps rocks. So this is the pile, concrete pile, pile. This is the reinforced beam. That's the beam on top of the pile, and there's a reinforcement bar and a cage shown around it. And the dots and dashes indicate the hatching for concrete. That's the symbol for concrete in that case. Here's the cavity wall sitting on top. This is the external, you can see, because there's the symbol for earth or soil. Yeah, so that's brickwork, and this is the blockwork. So that's the symbol for blockwork, and that's symbol for brickwork. And at this point here, well, we know what this is. This is the damp-proof course, DPC. Stops the water travelling up the wall. And this is the cavity fill. Some mass concrete, just put in the cavity there to stop the water, if it does get in, seeping through to the other side. Often you have a DPM, a damp-proof membrane, that comes up the wall here as well, okay, on the inside, and it stops any moisture coming up into the floor. Okay, internal blockwork this is. Oh, sorry, the external brickwork, sorry. Yeah. External brick work. There you go. Well done. Well, that was quite easy, wasn't it? Concrete there. Right, moving on. Now I've sketched this out a little bit to help you. And it asks, sketch a diagram of a cross section through a timber upper floor supported by joist hangers. Well, the joist hangers, they hold, I've got one sketched here, they hold the joists coming off the floor. New wooden joists. And they look something like this, with holes in where you can put screws in. And they have a metal plate welded on. It's all part of it, really. And the joists come out of here. The joists actually come out. There's the joist. And it's held in place. There you go, by the joist hanger. Does that help? And this joist hanger here is slotted into the wall, often like this. And I use a ruler, and I think you ought to in the exam to help, to show your cavity wall. That's the internal layer. The joist hangers only sit on the inside layer, or in between the inside layer blockwork. And this could be timber, or it could be blockwork. And there's your brickwork. So brickwork here, and you can use the same symbols that we showed on the other side. So this is brickwork. Like that. This is your cavity and the cavity insulation. Do that nice and quickly for you. All the way down. You'll have some wall ties every now and again built in. Wall ties holding it together every fourth row up and every 1.2 meters roughly. And then you'll have your joist hanger, which I showed here. And then underneath you'll have your ceiling plaster. There's the joist I've just put in. This is the joist going in to the joist hanger. Then on top you'll have your floorboarding here. And you could show it like that. Often it's not floorboarding as we know it, perhaps from many years ago. It's more chipboard, and it's usually about 22 millimeters thick floor boarding. And the joist hanger, label it up, is that there. That's the joist. That's the plaster ceiling board. Often you have obviously plaster on the inside of the wall there, as you want to just see blockwork. That's obviously a layer of plasterboard there. This is the block work, but it can be the brickwork. It all depends, but usually the brickwork's on the outside. And this is brick work. Okay, I think that covers it quite well. This is the joist here. We'll show it cut off. Brilliant. Okay, and we've got the cavity there, of course. Cavity, and that's the insulation. Insulation. Sorry, I'm rushing this a bit. Insulation. There you go. Be glass fibre. Below an area where you may get moisture, you have to use a different type of insulation, and it's a non-porous insulation which doesn't allow water to get into it or gather inside it. Of course, on the outside of blockwork, you can have render, can't you, on the outside, or even the more modern composite panelling. Often, if you've got the panelling on the outside, you just use blockwork on that external wall layer. Okay, this question here, number 6. One sustainable method of construction to minimise waste on site. And it says give 2 other sustainable methods. Okay. Give 2 other methods. Okay, right. So methods of reducing waste on site. This is what I do. I would use prefabricated structural panels. These are panels made off-site in a factory, which can be brought into site or onto site and form part of the actual housing or construction of whichever building you're trying to build. Often used actually for larger buildings, but I noticed that these panels are now being used more and more in domestic type work. Okay. And another way you can actually reduce waste on site is using a truss rafter. And these have been used for years. Now, truss rafters are the network of triangulations of timber, and they are very carefully nailed together with a nail plate called a gang nail plate, often here and here and here. And there's no waste because they're pre-made on site, and that reduces massively the amount of waste. And there's many of these that makes up a building, roof structure, and that's probably in some ways better than it being cut on site, where you can get a lot of wastage of materials. And of course you have to store that material before it's even put together on site or constructed on site. So these are brought in on lorries, craned in position, and you can have a roof put up within a few hours in some cases, the structure of the roof, that is. Explain here on question 7, explain 2 advantages of a raft foundation. As you know, the foundation is the part that holds up the whole building from the substrata in the ground, so load-bearing ground. And I suppose an answer to that is, I've put down in pencil, good in soil that is variable. Good in, I'm going to put earth that is variable. And that means variable in taking a load, okay? Not in the way it looks. So in the way it can take a load, or transfer the load, I suppose. And part 2 to this, can be used as part of a floor, and that's true. In the raft foundation you can build in the gas and electric service pipes, can be used as part of a floor, and therefore, you've actually formed a part of the floor as part of the foundation, so quite effective in that case. Raft foundation often looks something like this. Something like this, and the cavity walls come off it here. One cavity wall there, There's the cavity. That's your brickwork and block work. Your insulation goes in between, but this is your raft all the way across. There's it forming the floor as well. Good, that, isn't it? And then you'll have your DPC here. And you may have a membrane that goes across here, plastic membrane. And then your ground will be 2 bricks below that DPC, 150 millimeters. This is your earth. So DPC is 150 millimeters from the ground, and it stops the water splashing above the DPC and causing water to travel up the wall. I know that's quite small, but hopefully that helps. Moving on a little bit. Okay, explain 2 benefits to the community of a developer building on a brownfield site. Right, using old land is a good thing. Old land is reused or repurposed, people call it these days. E.g. for a new park. E.g. for a new park, which is great for society. And I've put less likely to be required, less likely to need the removal of trees, less likely to require the removal of trees. Okay, or you could actually put habitat as well. Living things habitat as well. And also they may have roads. Roads may already exist. So you don't have to build new roads. So I've put more than 2 points here. Now, greenfield sites, okay, the benefits to the community. Okay, do benefits. Greenfield sites are not are used. They don't. So they're not using new land. Green sites are therefore not used. Yeah, are not used. Less likely to cause flooding. Okay, because you're not using so much. You're not covering so much land. Less likely to cause new flooding. Yeah, because you're not covering the land. So it allows the land to be naturally draining if you're still using old land. Okay, I hope that helps. Question 9. Explain 2 advantages for a developer of using a flat roof instead of a pitched roof. Now, a pitched roof obviously is one which is sloping, like that. A pen's going, isn't it? And a flat roof obviously is quite the reverse. Literally is a flat. There's a flat roof. Right, so what's the advantage of using a flat roof? Wow, well, not that many, but I suppose you have less skill needed or required. You don't need skilled labour. It's quicker. Less time is needed to construct. That's a really important one. Remember, this is for the developer. Really important. Less material is needed. Yeah, much less is used this type of structure, isn't it? Over this type. Yeah, expensive. And I've got actually less. I know this is more than less need for storage on site. Less need for storage of materials on site as you're constructing. Okay, question 10. Hope we're doing quite well here. Explain one reason why a traditional cavity wall is less sustainable than modern forms. Okay. Brick and block walls are made from cement and clay-based materials, which are not finite. So, brick and blocks are made from finite. Get that right. Materials. E.G. Bricks are made from clay, and blocks are made from cement and aggregates. Okay, stone, I suppose, and sand. Types of stones and types of sands. An aggregate is a type of stone. Good. 11. Explain 2 advantages for a developer of using a prefabricated concrete wall. Prefabricated, that's pre-made. And concrete cross wall is obviously when you have an arrangement. We have one in 3D, one wall going that way and one wall going that way. Okay, something like that. There you go. Something like that. Cross wall. Okay, a lot of the new and some of the older housing developments were made like this. What are the advantages? Well, interesting. Cross wall construction from building a 2-story apartment block. Disadvantages. Interesting question. They can be less attractive. Okay. I'm using prefabricated. Yeah, less attractive. Oh dear, it's quite a hard question. It's less attractive, and I suppose can require specialist labour at construction and then putting in place and machinery or plant. It's called machinery. It's actually to lift them in place. Right. A disadvantage might be you can't adapt them. Cannot adapt after installation. You can't change them. You can't cut holes very easily in them. Often it's very difficult because you've got the reinforcement concrete, so you can't just decide to put another wall window in it if you wanted to. Right, okay, moving on. Last question of the paper. A local council is planning to build a large housing estate. 2 forms of wall construction are being considered: cavity and structural insulated panels. These pre-formed panels made in a factory off-site. Right, let's look at this. This is quite an important question. It's worth 8 marks. So cavity wall can be attractive. Can be attractive to look at. That's a good point. Requires on-site skilled labour. Requires on-site skilled labour. Can be slow to construct. Can be slow to construct. construct. Expensive use of materials. Expensive use of materials. Make sure your spellings are correct as best you can. Always helps. Not very sustainable unless timber. Now you can use timber for making cavity wall construction, but I'm assuming they're talking about brick and block type construction. So I'm going to put that. Not very sustainable unless timber based. Now interestingly, it can only be a softwood one as well. It has to be softwood. If it's hardwood, that's not sustainable because they're slow growing timbers. You also should mention that the U value, which is a value that measures the amount of heat loss through a material, can be much poorer. So U values can be poorer, so less effective in stopping or reducing heat loss, okay, through the wall. And you get U values that relate to glass as well, and windows and so forth. And lastly, site materials need to be stored and made secure from theft. It's a big problem on some sites. Now the SIPs, which is the structural insulated panels, different kettle of fish this. It's almost the reverse in some ways. Can be much better at reducing heat loss. Can be much better in reducing heat loss. So the U value is improved. Very fast to put in place. Very fast to put in place. And so you have a reduced cost. I think that's a good point. Specialist skills, however, are needed on site. Specialist skilled labour required. Okay, not all the time, just when it's been put in place on site. Can include electrical and water and gas pipes. Can be designed to include. Now, this is the word services. Try and get to know that word. Electrics, gas, water, and intercom or communication lines. Cabling, I suppose. Quality can be easier to control. Yes, can be. Quality can be easier to control. That's certainly the case. Cannot be left uncovered. Yeah, while it's being constructed, you can't let it get wet. Must be covered whilst installed. Can be pre-covered in a range of finishes. Yes, can be pre-covered in the factory with a wide range of finishes. Or they call it cladding. Okay. Can be easily damaged. Oh yeah, can be easily damaged. Ooh. on site. Must be looked after. Okay, I think that's the crux to it all. Gives you a bit of an overview of how you can do an exam. You have to work fast, look at the amount of marks, read your questions carefully, highlight the most important points, and I would always review what you've done afterwards. Just go back and see what you've done and see if you've missed bits out. I think if you did something like that, I think you're in with a good chance. Okay, good luck to you, all of you. Goodbye.